doing values of functions, and we talked about this example of how we can use calculus to help us find maxes or mins. And what you have been tasked with doing is answering these questions about this kind of funky piecewise function that we were given here. The first thing we were asked to find are the zeros of f. And what do we get for the zeros of f? Start from left to right, please. Austin, can you help me? A, C, G, and what? K. Looks good. All right. And points of discontinuity. Remember, if we're looking for a point of discontinuity on F, then we are looking for where we have to lift our pencil. That's the simple rule to think about. And the only place I have to lift my pencil is where? At H. All right. Points where F prime does not exist. So what are we looking for if we want to know where F prime does not exist? James? Corner? Cusp? Jump? Other discontinuities. I like an asymptote. So James, what did you get for this one?
I said
B as in boy?
yeah.
Yep. A looks good.
I and J.
I and J. Yes. So we have a cusp, we have an asymptotic discontinuity, or an infinite discontinuity, and then we have a sharp turn and a sharp turn. So that looks good to me. All right, moving on. We won't see the picture anymore, but let's fill in what we found. This is letter D, points where F prime equals 0. Joey, help me with that one. This is letter D.
I said F equals F, K, M, D.
F, K, M, and what else?
D.
D as in dog, yep. And there's a little more.
H through I.
H through I. With bracket notation, I would do parenthesis H comma I, because the derivative equals 0 everywhere in there. Okay? Critical point, that is where the derivative equals 0 or is undefined. Daniel?
It said F, and then like on the interval H I, and then K and M. I don't know if that's the right one. Oh, yes.
Just, I think one being left off. Maybe two. Oh, I've got a few more. Yeah. Anybody else have any others on that one? Yeah. Parents?
B.
B is in boy. What else?
H.
Got H.
J.
J. And I heard
D.
D also. Those are all correct. We're looking for any places where it would have a horizontal tangent line or where it has a sharp turn or a discontinuity. Did you have it, James?
Yeah, I just thought it was B that we were in.
Oh!
Yeah.
Oh, okay. Gotcha. All right. All right, F. I'm on F now. Critical points that are not stationary points. Landon, you have that one.
B, H, I, J.
B, H, I, and J. Good. Intervals over which F increases. This is letter G. Derek?
B, D,
And?
D to F, J, K, and M to infinity.
Let's see if I agree. B to F. Yep, B to D, B to F, J to K, and M to infinity. You'll see when I show you the solutions that they wrote this as one interval, even though D is it's at 0 at D. We cannot be increasing or decreasing at one point, so that's why it was okay to go B to F, but it's perfectly fine to go B to D and D to F. If that makes more sense to you, you do it that way. How about H, intervals where F decreases? Monica, did you get that one?
I have it, I think.
Okay.
I did X is less than B.
Yep,
and
so
then-
negative infinity to B.
Yeah.
What else?
S to H,
F to H.
I to J,
I to j,
K to N.
and k to m. That was good. Good. Relative maxima. Zach, how about that one?
I got F and J.
F and K, and one more region,
H down.
H to I. Because we have that horizontal part.
So on a horizontal line, it's just always a maximum and a minimum?
Yep. See, that's the general rule, is that they're all maximum points and all minimum points. All right, J, absolute maxima. AJ, what do we got? F. All right, relative minima. On this one, Natalie, help me with that one.
J and M.
Relative, what one is this? K?
Yeah.
Say them again.
B, J, and M.
B, J, and M, and also?
H, I.
Yep. H to I. All right, absolute minima. There is not one. And that is because at letter H, we have an asymptote, so from the left, G goes down forever. That's why we do not have an absolute minima. I know lots of people look at the two local minimas trying to figure out which one's lower, but it's the asymptote that causes there to not be an absolute minima. Okay, moving on. Find the equation of any horizontal asymptote. What did we think on that one, Justin?
Well, I was confused, is where the derivative equals 0 considered the horizontal?
No, end behavior, far to the right and far to the left.
Yeah, so,
Well, I considered the right end to be one. Looked to me like it was going y equals 0, but I could see how it is a judgment call, because we can't really tell what is approaching. It looked like that to me, so I went with it. All right, an equation of the vertical asymptote. Michael? Oh, sorry. I meant Harris. Sorry.
at x equals 8.
X equals h. Good. All right. Find the x-coordinate of each point of discontinuity of f prime. Well, I had to sketch f prime to think about these. Just made it easier for me. So let me show you the solution to the f prime graph, which is here. Now, I don't care what your concavity is on these right now. That's not what we were looking for. We just want the general trend. So check your answer to number 4 and to your graph. Any questions on these? Yes.
Can you walk through it?
So I can do a little bit. I'm going to run short on time. So starting on the far left, the slope here is a negative value. Okay? And as it moves, is the dashed line the original? It is, right? Okay. So as we move closer and closer to x equals b, they're becoming more and more negative. So we start at a small negative and we move to a very large negative. You could have had an asymptote here. That would have been acceptable too, or the whole. Then if we move just to the right of the cusp, we immediately have a very large positive slope. So that moves us above the x-axis, way up here. That's what's going on between B and up until D. And at D we have a slope of what? We have a slope of 0, so that means my f prime graph should touch the x-axis at B. Then we have a 0 here and we have a 0 here with the biggest slope in between, so that's when we get this hump. Then to the right of the peak over here, the slope starts at 0 and becomes more and more negative, so that's where this asymptote comes in here. Now to the right of h, the slope everywhere between h and I is 0, and we're undefined at h and undefined at I, because we have a sharp turn and a discontinuity. From here to here, all of those slopes would be something like -5. So it will be a horizontal line at -5-ish. I'm making up that number. And again, undefined at I and j because of the sharp turn. Just to the right of the sharp turn, we have a positive slope heading to 0. So we start up here with a positive slope heading to 0. Then once again, I have a 0 and a 0 with the largest value in between. All the slopes are negative. So that's why we get this big dip right here. And we have a 0, and it looks like it's going to 0 here with the biggest in between. So that's how we get this hump up here, and then we slide to 0. Okay? All right. Now, before we leave, I want to do one problem, finding the extrema analytically. That is without a graph, sometimes without a calculator. We need to be able to do that. So, finding extreme values, that means we're looking for absolute and local maxes and mins. If I run short on time, your homework is on the assignment sheet. It's updated on the website. And I'll finish this example outside of class, so it'll be on the video tonight. Okay, if I run short. All right. So, we said earlier that all of our maxes and mins are going to happen at critical points. And I want you to also make a point that maxes and mins will happen at critical points or at endpoints, if we are given endpoints. So for example, if I have a graph that looks like this, we definitely still have a local max at the left endpoint. Here we would have a local min. This would be a what? Local max. Here, local min. And what about that? Local max and absolute max. And this one would have been a local min and absolute min. Okay? So that means if it is a closed interval and we have endpoints, you must always look at the endpoints and compare the y values to see if the absolute max is happening at the endpoint. Okay? You'll get more practice with that. All right, and critical points are where f prime equals 0 or is undefined. Well, if I want to find where my extrema happen, that means I need to find where the critical points are. So, let's think of what is the derivative of this function. Well, we need to figure out what's happening at x equals 1, but we can find the derivative when x is less than 1 and when x is greater than 1. So what is the derivative when x is less than 1? Negative 4x. And when x is greater than 1? 1. So, I asked you the question, does the derivative exist at x equals 1? I'm hearing no's. Why? Is that a cusp? I hear that. How do we know? Left derivative and right derivative are not the same. Left derivative is what? At x equals 1? Equals negative 4 at x equals 1? And the right derivative? Equals 1. At x equals 1. So that means the derivative does not exist at x equals 1. Well, that means x equals 1 is a critical point. Because that's where the derivative is undefined. Right? Critical points are where the derivative equals 0 or where it is undefined. So there's one of our critical points. Where's the other one? At x equals 0, because that makes our derivative equal 0. Now, we just want to find out if we have a max or min. Well, our maxes and mins are only going to happen at those critical points. So if we just look to the left and right of those critical points, we can tell if it's the biggest in its neighborhood or the smallest in its neighborhood. So what we want to look at is f of 0 and f of 1. And just to the left of f of 0, I'll take f of negative 1. F of what here? Between 0, we'll need f of 2 also on the outside of that one. What will I need here between 0 and 1? Maybe 1/2. And we are just going to compare their y values right now to see if we have local maxes or local mins. So f of -1 will be what?
4.
It will be 4. We're just plugging into the original function. F of 0. Sorry, get back up there. F of 0 will be what? 5 minus 0, or just 5? F of 1/2. Is what? 4.5? So tell me, f of 0, or at x equals 0, we have a local what? Local max. All right, f of 1? Still going to use this branch. It's going to be what? 3. And f of 2? 2 plus 2 is 4. So at x equals 1, we have local max. Homework is on the assignment sheet on the website.